Alrighty, so today we're going to be having a look at finding tangents of functions. So just as a quick reminder, if we have some function f of x and we want to evaluate it at a point, let's say the point a comma f of a, the tangent is the straight line that passes through that point and has the slope of the function. So this line here is the tangent line. Okay, and an important part about a tangent line is its function, let's say g of x, is going to be a linear equation, so mx plus c, but in particular, the gradient is going to be equal to the derivative of the function at the point a. So let's see how we actually do that. So consider the function y is equal to x squared minus x minus 1. Determine the equation of the tangent to the graph at x equals 3. So first of all, let's find our gradient function. So dy dx is equal to 2x minus 1. Alrighty, and we're going to substitute into that equation x equals 3 to find out the gradient. So we get dy dx 2 times 3 minus 1, 6 minus 1 is 5. All right, so therefore the gradient there is 5, which is going to be our m value. So our tangent function, let's call it y is equal to mx plus c. The m value is going to be 5. So what's the only information we need left? Well, for it to be a completed linear function, we need a plus c, so we need to find the y-intercept. Now, we need to substitute in a point that we know. We know it passes through the point x equals 3. But we need to know the y-coordinate that goes with x equals 3. So let's substitute x equals 3 into y equals x squared minus x plus 1. We get 3 squared minus 3 minus 1. 9 minus 3 is 6. Minus 1 is 5. So this is the point 3, 5. So let's now go back to my linear function, my tangent function, and we're going to sub in the point 3, 5 because it needs to go through that point, otherwise it wouldn't be a tangent. It'd have the right gradient, but it'd be in the wrong spot. 5 is equal to 5 times 3 plus c. 5 is equal to 15 plus c. We can subtract 15 from both sides and we get negative 10 is equal to c. So my final equation, the tangent at x equals 3 is y is equal to 5x minus 10. So that is the tangent function at x equals 3. Let's have a look at another application of tangent. Alrighty, so determine the coordinates of the points on the graph y is equal to 2x to the 3 minus 3x to the 2, at which the tangents are parallel to the line y is equal to 12x minus 1. Alrighty, parallel lines. What's true about parallel lines? Parallel lines have gradients which are the same. So we need to look for points that have a gradient of 12. So we're looking for points where dy dx is equal to 12, because that's the gradient of that function. Alrighty, so let's work out what dy dx is. So the original function is 2x to the 3, bring the 3 down, reduce 3 to a 2, and then bring the 2 down, and reduce the 2 to a 1. Simplify, and we get 6x squared minus 6x. And we're looking for when that function is equal to 12. Alrighty, so this is just solving a quadratic. Let's go through it. 0 is equal to 6x squared minus 6x minus 12. Factorize out the factor of 6. We can now cancel that in a sense. So now we just need to factorize the inner bit. Something that multiplies to equal negative 2 and adds to negative 1. This can only be negative 2 plus negative 1. So that means we can directly factorize this, for it is a monic function. And we get x minus 2 x plus 1. And so by null factor, this solves to two different solutions. X is equal to 2 or x is equal to -1. But once again, this only tells me half of the coordinate. For a true coordinate, we need to know the y value. So we need to go back and substitute into our original function y. So first solution was x equals 2, and we're going to sub that into y is equal to 2. 2 to the 3 minus 3, 2 squared. 2 to the 3 is 8 times 2 is 16, minus 3 times 4 is minus 12. So the first point is 2, 4. Second point is when x equals -1. Y is equal to 2 times -1 to the power of 3 minus 3 times. -1 to the power of 3 is -1, so we get -2 minus 3 times -1 squared. -1 squared is 1, so -3 times 1 is just -3, and we get -5. So the 2 points are -1, -5, and 2, 4. And those are the two coordinates. Alrighty. Thanks for watching. See you in the next one. Bye.